Hi everyone, this is Eva at Industrial Sonomechanics. For today's Q&A video, I have invited Dr. Alexey Pashkovsky, President and Chief Scientific Officer at Industrial Sonomechanics, to join us. Alexey, can you provide an overview of the process of making water-soluble liquid and powdered nanoemulsions with the ISP-3600 ultrasonic processor configured in the flow-through mode?
Hi everyone, thanks for this question. I'll be happy to give you guys an overview. The first question is, what type of nanoemulsion are you making? You could be making a liquid translucent nanoemulsion. For that, you would need nanostabilizer LT and your cannabis extract or another bioactive extract type. Or you could be making a water-soluble powdered nanoemulsion. For that, you would need nanostabilizer LSO and your cannabis extract or another bioactive. The only requirement for this bioactive is that it has to be oil soluble or lipophilic. As the first step, you would take your nanostabilizer. Let's say we're making a liquid translucent nanoemulsion. You would take the appropriate amount of nanostabilizer LT, place it in this container. That would be on the magnetic stir, or you could use an overhead mixer. You would need to warm it up to melt it. It melts very easily at about 50 degrees Celsius. It's pretty much in the liquid state. Then you would separately pre-melt your cannabis extract or another bioactive, place the appropriate amount of that into the nanostabilizer. They would melt together. And you would stir this on the magnetic stir or, again, on an overhead mixer as an option. Nanostabilizer LT dissolves lipophilic substances, including cannabis extracts. So you will have basically an oil phase pre-made. Separately from that, in this storage mixing tank, equipped with a magnetically driven mixer, you will have the appropriate amount of water gently mixing in this tank. You will open up this lid, put your oil phase, which is nanostabilizer LT and cannabis extract, into the water phase as it's being mixed with a vortex. So at this point, you don't have anything flowing out of it or back into it. Everything is just sitting in this tank. So within this tank, you're going to mix it, and that will make a crude emulsion, sort of a precursor for the nanoemulsion. Once you don't have any chunks floating, when it's all kind of milky and roughly homogeneous, you will open up this valve and start the pump, which will take the premix into the reactor chamber, out this side, through the heat exchanger, and back into the tank. This is your loop. Once your loop is set up and your liquid is flowing like this, you can turn on ultrasound. The barbel horn, which is inserted into the flow cell or this reactor chamber, will activate. This barbel horn can provide up to 100 microns peak-to-peak ultrasonic amplitude, and it has a 45 millimeter diameter tip, which creates an extremely high acoustic cavitation inside this reactor chamber. Typically, 100 microns is a bit too much, so you normally would operate at about 80% of that value, which is about 80 microns peak-to-peak. This cavitation is the force behind the process. That's what's responsible for the creation of the extremely small droplets of oil suspended in water, which is the nanoemulsion. So once the liquid is flowing and you have your ultrasound on, there is going to be cavitation in this chamber, and you're taking the premix, which progressively becomes the nanoemulsion as the time passes. So the liquid will be going around, and you can watch it through this hose, or you can incorporate side glass if you desire, and watch the liquid become progressively more and more translucent. When the process is done, you should be able to see light through this. You should be able to read text through it. And if you have like a laser pointer, it's good to have it point from the other side back towards yourself, and you should be able to see a focused beam. It shouldn't be scattering. So when you clearly see that beam, that typically means that the process is done. And you should expect to be able to process approximately 20 liters of nanoemulsion in 1 hour with the system, which is about half the tank. This is a 50-liter tank. And at the end of this process, when everything is done, you can expect a nanomulsion with the droplet size, medium droplet size of approximately 25 to 30 nanometers. Once the process is done, you stop the ultrasound, you stop the pump, reverse the flow direction of the pump, start it up again. That will collect all the liquid back into the tank. Once all the lines and the heat exchanger and reactor chamber, everything is purged, you can close this valve, and now you have all of your nanomulsion here. It's also important to point out that this heat exchanger is there to maintain the temperature of the liquid that you're processing at the right level. We recommend approximately 50 degrees. It could be anywhere between 40 and 60 degrees throughout processing. And there is a thermometer that you can use at the tank that will tell you what the temperature is. It's also important to continuously cool the transducer. Both the transducer and the heat exchanger require chilled water from a common chiller. It's back here. And then the lines are split and channeled appropriately. So some of the water goes to cool your liquid. Some of the water goes to cool your transducer. You don't ever have to worry about it. It's going to take care of itself. So as the process goes on, just watch it and make sure that everything is operating properly, but there's nothing you have to do. So once the process is done and you've collected all your liquid here, you will disconnect the line from here. You will connect it to this filter. You'll again reverse the flow and slow it down. And then you'll just pass all of this liquid using this pump through this filter into your finished product container. The filter is there to sterilize your nanomulsion. This is a sterilizing filter, 220 nanometer pore size. Once the liquid passes through this filter, it's sterile. You collect it in the finished product container, and you're done. Now, if you're making a powdered nanomulsion, you will need a different type of nanostabilizer LSO. This is not a liquid, it's a powder. It will not melt. So we're not going to do any of this. We're not going to be pre-mixing. You have your water in this tank. After that, you place the appropriate amount of nanostabilizer LSO into this tank. The mixer will make sure that everything is homogeneously dispersed in there. And this is before you've opened up any of the lines. Then you dispense the appropriate amount of your cannabis extract or another bioactive extract into here. Once everything is pre-mixed and you have your crude pre-emulsion, then the process is exactly the same, except you can't expect this to be translucent. It will not be. Nanostabilizer LSO does not lead to translucent nanomulsions. You can either measure droplet sizes, and once they stop going down, they should stabilize at approximately 150 nanometers. Once you reach 150 nanometers for the medium droplet size, the process is finished. Or you could just give it approximately an hour for every 20 liters. So if you're processing 20 liters, it's going to take an hour. If you're processing 40 liters, it's going to take 2 hours. You can just run for 2 hours and then stop. After that, again, you purge all the lines. The same story applies to the temperature. You need to maintain temperature between 40 and 60 degrees Celsius. You purge all the lines. You collect everything in here, and then you use a different filter, this one. So again, you disconnect this, connect this filter. This is a 1.2 micron filter because the droplets are now bigger. You will then reverse the flow of the pump, slow it down, and collect carefully this nanomulsion through this filter into your finished product container. If you're making a powder, that's not the end of the process. Now you have your nanoemulsion made with nanostabilizer LSO, which will then need to go through a drying process, which is a whole different conversation, and that will yield a water-soluble nanoemulsion powder, which you can reconstitute in water back into the original nanoemulsion with the droplet sizes of approximately 150, 170 nanometers in size.
Thanks for that overview, Alexei. If you have any questions or you need information on our ultrasonic processors and nanostabilizer, please comment below or contact us through our website, sonomechanics.com. In the description of this video, I have also included a link to a piece of content that is relevant to today's topic, a nanostabilizer comparison chart, as well as a link where you can access our web store. to view pricing and additional information on those products. So be sure to check those out. Thanks for watching. See you next time.